welcome to True Projects. In this video, we are going to discuss about the project title, which is Sentiment Analysis of Weibo Comments based on Graph Neural Network. In the era of rapidly expanding online social platforms like Weibo, comprehending sentiment trends within user comments is paramount. Traditional sentiment analysis struggles with non-standard internet expressions, yielding suboptimal results. To address this, the project introduces an innovative approach that melds graph neural network and LSTM, preserving semantic rules and structural dependencies in short text. By converting text classification into graph classification using syntactic dependency trees, this method substantially boosts sentiment analysis accuracy for Weibo comments. This project promises valuable insights for platforms and governments, facilitating a deeper understanding of user opinions, enhancing interactions, and aiding informed decisions. The project's aim is to elevate the field of sentiment analysis for Weibo comments on online social platforms by conducting a comprehensive assessment and comparison of various cutting-edge natural language processing algorithms. These include GCN, GRU, LSTM, CNN, BiLSTM, BERT and hybrid models such as BERT GCN with LSTM. The primary objective is to effectively address the challenges presented by the informal language commonly found in user comments and to enhance the precision of sentiment classification. By harnessing these algorithms alongside innovative techniques like syntactic graph analysis, the project seeks to extract valuable sentiment insights from vast textual data. Ultimately, the project endeavors to equip platforms, governments, and decision makers with improved tools to grasp public opinion trends and optimization interaction strategies. Coming to requirements, we need hardware requirements. In that, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need Anaconda 3 and Visual Studio Community version. In flow of work, we have designed few modules to execute the project. The first one is importing the packages. In this module, we import the necessary libraries and packages which are Pandas for data manipulation, NumPy for mathematical calculation, Matplotlib and Seaborn for visualization, sklearn for machine learning, and TensorFlow Keras for deep learning. Coming to exploring the dataset, this step involves dealing into the dataset to understand its structure, contents, and statistics. During this phase, we explore the data to gain insights into its characteristics. Third one is data processing. This module involves preparing the dataset for analysis and modeling. Key tasks include data cleaning, handling missing values, and feature engineering to ensure data quality. Fourth one is visualization using Seaborn and Matplotlib. In this module, we create visual representations for data using Seaborn and Matplotlib. This step helps in visually identifying patterns and relationships within the dataset. Next one is data cleaning. This step involves cleaning the data by addressing issues such as duplicates, outliers, and inconsistencies. In this, we aim to improve data quality. Coming to next one, which is tokenization based on BERT for TL and Keras for deep learning. This module involves tokenization is performed to break down text data into smaller units or tokens. In this phase, we utilize BERT for transfer learning and Keras for deep learning tokenization. Next one is splitting the dataset into train and test. This module involves splitting the dataset into two subsets, which are a training set and a testing set. The training set is used for model training, while the testing set is for evaluation. Coming to the next module, which is building the model. In this step, various machine learning and deep learning models are built. The first one is GCN, which is Graph Convolutional Network. It is a type of deep learning algorithm designed for graph structured data. It performs convolutional operations on graphs to learn representations of nodes that take into account the relationships between them. It is employed in this project to capture structural dependencies in the data, making it suitable for tasks like sentiment analysis when considering the interconnectedness of comments and user interactions. Next one is GRU, which is Gated Recurrent Unit. It is a type of recurrent neural network, which is RNN, that is designed to capture sequential dependencies in the data. It uses gated mechanisms to selectively update and reset information in the hidden state. It is effective for sequential data like text because it can capture context and dependencies over time, which is essential for understanding sentiment in textual data. Next one is LSTM, which is long short-term memory. It is another type of recurrent neural network that is designed to handle long-range dependencies in sequential data. It uses memory cells and gating mechanisms to store and retrieve information over long sequences. It is well suited for tasks like sentiment analysis because it can capture context and dependencies in text while mitigating the vanishing gradient problem common in traditional RNNs. The next one is CNN, which is convolutional neural networks. It is a deep learning algorithm primarily used for image processing. It can be also adapted for text data. It uses convolutional layers to learn hierarchical features from the data. It is used for text data by treating text as image where the words or tokens are treated as pixels. It is effective at capturing local features and patterns within text. Coming to BiLSTM, which is bidirectional long short-term memory. It is an extension of LSTM that processes the data in both forward and backward directions. This allows it to capture context from both past and future information. It is used for sentiment analysis to leverage bidirectional context, which is valuable for understanding sentiment nuances in text. Next one is BERT, which is bidirectional encoder representer for transformations. With GCN, LSTM, combination of BERT, GCN and LSTM. This is combination of integrates BERT, GCN and LSTM to leverage both pre-trained contextual embeddings from BERT and structural dependencies captured by GCN and LSTM. It is used to combine the strengths of these three approaches to improve the accuracy and effectiveness of sentiment analysis by considering both contextual and structural information. Next one is BERT. It is bidirectional encoder representation from transformers. It is a transformer-based language model that captures contextual information from a large corpus of text. It has revolutionized natural language understanding tasks by pre-training or vast text data. It is employed because of its ability to capture rich contextual information, which is crucial for understanding sentiment in text. It excels in capturing nuances and context. Next one is LSTM with CNN, which is combination of LSTM and CNN. This is hybrid model that combines the strengths of LSTM and CNN. It uses LSTM for sequential understanding and CNN for local feature extraction. This combination is used to leverage both the ability of LSTM to capture sequential dependencies and the strength of CNN in capturing local text patterns, providing a more comprehensive understanding of sentiment. The next module is training the model. After model construction, this module entails training the model on the trained data. During this phase, model learns patterns and relationships within the data. The next one is Flask framework with SQLite for sign up and sign in. In this module, we implement a web application using the Flask framework and incorporate SQLite for user sign up and sign in functionalities enabling user interactions. Coming to the next module, which is user gives input. In this module, user provide input through the web interface. The next one is train model for prediction. The trained machine learning for deep learning model is employed to make predictions based on the user's input. Next one is final outcome displayed through frontend. This results of the prediction are represented to the user through the project's frontend, providing insights for classification outcomes. This is the comparison graph of the project. On x-axis, we have the accuracy scores, and on the y-axis, we have the algorithm names. Here are the accuracy scores of each particular algorithm. Among all the algorithms, LSTM and BERT GCN with LSTM is performing well. Coming to execution, first we need to open the code folder which contains the source codes. This is the code folder of the project, and this is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This file contains the information related to the front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are the model files which will contain the algorithm information, and these will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows user to write and execute code in individual cells. This is the sign up file. This file is the database file used to store the user information. Now we need to copy the code folder address, which is path, from the file explorer and open the Anaconda prompt. Here, using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change the current directory to the code folder's path. Now we need to type python space app.py. This will compile app.py file using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on the button enter. So, after running the app.py file, the Flask framework will host the application locally at the default address, which is 127.001, which is this one, and the port number, which is this one. Now we need to copy this local link and paste it in any browser. I will paste it in the Google Chrome. Here I will paste it and click on enter. Here the home page of the project is displayed in the browser, and this front end is built using the Flask framework. This is the web page developed by the using Flask framework. Now we need to click on sign up. Here we need to give all these details if we are registering newly. I have already registered, so I will directly click on the button sign in. Here I need to give my credentials, which are username and password, to log in. Now I will click on login. So this has redirected to the home page. Here we need to give the input message, and for that message the sentiment will be predicted. So I will give the message here. I have given the text here. Now I will click on predict and see what will be predicted for this particular text. So for this particular text, we have the sentiment of the text is negative, which means the predicted sentiment is negative. Now we will try with the other text. Here I'll give the other message. I gave the other message here, and now I will click on predict. Here it has predicted that the sentiment of the text is positive. Now I will give the other text. I entered the message here and click on predict. So for this particular text, it has predicted that the sentiment of the text is negative. Now we will try with the other text. I entered the other text and click on predict. So this particular text that is predicted as the sentiment of the text is positive. In this way we can give any text message. For that text, it will predict whether the text is positive or negative. Now we will sign out. The project included a thorough examination of several natural language processing techniques for Weibo command sentiment analysis. Through extensive testing, we discovered that certain algorithms like LSTM outperforms other in capturing sentiment patterns in the setting of non-standard online language. These findings highlight that the necessity of choosing proper algorithm to solve the specific issues given by user-generated material on online social networks. Finally, this project contributes to the evolution of sentiment analysis methodologies, allowing for better knowledge of public opinion patterns and improving engagement tactics for both platforms and governments.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.